Welcome to homework.
So this would be the free body diagram for the system that we have here. And we're going to apply Newton's second law to both masses. So for mass sub A, we have the sum of forces in the x direction. This is going to be equal to force tension minus m sub A g sine of theta sub A. This is equaling m sub A times A. For the mass sub B, we have the sum of forces in the x direction equaling m sub b times g times sine of theta sub b. This is going to be minus force tension. This will equal m sub b times a. And now we're going to add these two equations together. We can say force tension minus m sub a g sine of theta sub a plus m sub b g sine of theta sub b minus force of tension. This would equal m sub a times a plus m sub b times a. Force tension, of course, cancels out, and we find that the acceleration is going to be equal to m sub b times sine of theta sub b minus mass of a times sine of theta sub a. This would all be divided by the total mass. So this would be our answer for part A. Now, for the for part B, for the acceleration to be at rest, so at rest, this means that the acceleration must equal 0 meters per second squared. Therefore, the acceleration would equal m sub b again, sine of theta sub b, minus mass of a sine of theta sub a, divided by mass of a plus mass of b. And I forgot for this part, there's a factor of g that my apologies. Just realized. So this entire term would be times the acceleration due to gravity. Okay. So here, and then it'll be times g. This would equal 0. At this point, if this equals 0, this means that mass sub b times sine of theta sub b would be equal to mass of a times sine of theta sub a. Therefore, mass of b would be equal to mass of a times sine of theta sub a divided by sine of theta sub b. This is going to equal 5.0 kilograms multiplied by sine of 32 degrees divided by sine of 23 degrees. And this is equaling 6.8 kilograms. So if the mass of block A is equaling 5 kilograms and the mass of block B is equaling 6.8 kilograms, the system will be at rest and acceleration would be equal to 0 meters per second. If we wanted to find the tension here, we can say that for the mass of A, the force tension minus mass sub A times g sine of theta sub A, this is equaling 0. And so the force tension would simply be equal to the mass of A, 5.0 kilograms, multiplied by the acceleration due to gravity, 9.80 meters per second squared, times sine of 32 degrees. And we find that the force tension is going to be 26 newtons if the system is at rest. And for part B, sorry, for part C, just like in part B, the acceleration will be 0 for a constant velocity. So we can say for constant velocity, the acceleration is again 0 meters per second squared. Therefore, the same exact relationship applies. However, we can say that the mass of A divided by the mass of B then equals g sine of theta sub b divided by g sine of theta sub a. The g's cancel out, and we have sine of 23 degrees divided by sine of 32 degrees. This is equaling 0.74. So that would be your answer for part C. That is the end of the solution. Thank you for watching.